This is AB Calculus homework help, and it's going to be on this exercise that I obtained from some Algebra 2 problems a while back. And with these expressions, what we're going to do is change them into this type of arrangement. So we're going to do 4, 5, 6, and 7. So we're going to change this expression into f prime of x equals 5x squared plus 7x plus 2. And from this function, for the first derivative, I'm asking my students to find increasing, decreasing intervals, relative max and mins, and really where we have relative max and mins, and also our points of inflection, if any. So I'm going to go, and what you'd do is the first step would be factoring this and setting this f prime of x equal to 0, find the points at rest, and in the future we're going to go backwards to an antiderive and get to f. But in this exercise, I'm going to actually do problem 6, which is similar to the others. So 4, 5, 6, and 7. So I'm going to say f prime of x is equal to 4x squared plus 5x minus 6. And then find the various things that I previously mentioned. So I'm going to go ahead and factor this function, and we have a is equal to 4, b is equal to 5, and c is equal to negative 6. So using the x method, AC we put up here is going to be negative 6 times 4, which is negative 24. And down here below we have b, and b is 5. So what two numbers will add together to equal 5, but when multiplied together equal negative 24? Well, how about 8 and 3 being part of that? So I'm going to put 8 on one side here and 3 on the other side. And then, let's see, 5 is positive 5, so we're going to have negative 3. And we're going to divide out by a, and a is 4. Okay, so we have 8 over 4 simplifies to 2. And so for our factoring, we're going to have x plus 2, and then we're going to have quantity x minus 3/4. And using the bottoms up method here, we're going to have x plus 2 times, we take this 4, put it up there with the x, we have 4x minus 3. So now we're going to say f prime of x in factored form is quantity x plus 2 times quantity 4x minus 3. And if we multiplied these back in the other direction, we would see that indeed is the correct factoring. And so setting f prime of x equal to 0, we have 0 equals quantity x plus 2 times quantity 4x minus 3. We can use the zero factor property to solve for x. We have x plus 2 is equal to 0, and the other factor is going to be 4x minus 3 is equal to 0. And solving for x is equal to negative 2. And on the other side, if we bring the 3 over to the other side, we're going to have x is equal to 3/4. So there we have our critical numbers. I'm going to make a number line below here, and I'm going to put -2, and then 3/4 over here to the right, and then f prime above and f below. And so for a number less than -2, we're going to have a negative times a negative, which is positive. So we are increasing. Now this is not f prime of x is increasing, it's f of x. And we don't have f of x here. We just have the function of f prime of x. We could anti-derive and get a possible version of f of x. And next we have, if we pick 0, we would have positive times a negative. And then to the right of 3/4, we have a positive times a positive. So we have a relative max at x equals -2 because f prime of x changes from positive to negative. Okay, we have a relative minimum at x equals 3/4 and y because f prime changes from negative to plus to positive. Okay, and now we can also do the increasing decreasing intervals. So increasing on intervals of, it's supposed to be on, doesn't look very good. Okay, negative infinity to -2, and also from 3/4 to less than infinity because y, f prime of x is greater than 0 on this interval. And decreasing on, we have -2 greater than -2 less than 3/4 y because f prime of x is less than 0 over this interval. Next, points of inflection. Okay, we're going to have the second derivative, so I'm going to arrow over here to the right, open space here. F double prime of x is equal to 8x plus 5. And then to find the points of inflection, if we replace f double prime of x with 0, we have 0 equals 8x plus 5. And if we solve for x, we have -5 is equal to 8x, and then x is equal to -5/8. And we could make another number line, in this case for a -5/8 f double prime, f below here, and to the left of -5/8, we could say, oh, -6 or whatever, -5, we'll have negative or concave down over that interval. And greater than 5/8, say we plug in 0, we're going to get f double prime being positive, which means the original function f is concave up. So we say there's a point of inflection at x equals -5/8 because f double prime changes from negative to positive. Just put a plus sign. Okay, and that's it. And as far as concavity, we could say concave down on -infinity to -5/8 because f double prime is less than 0, and concave up on the interval of -5/8 to infinity because f double prime of x is greater than 0. And then we could do a curve sketch of what the graph of f of x looks like. But I'm going to look to the future for that. So I encourage the viewer to look at problems 4, handle 5 in the same manner. F prime of x equals x squared minus 12x plus 36, and work out those things and go to number 7. F prime of x equals 6x cubed plus 18x squared, and work this out in the same manner. And that's all I have for you now. Good luck, and thanks for viewing.